Yeah. Today we're going to talk about function notation, section 1.7. So yesterday, remember, we talked about relations and functions. We talked about domain and range. Domain is always my what values? X. Range is always my Y. Today we're going to talk about function notation. Okay. So basically, today we're going to be evaluating some functions. First thing we're going to talk about is function notation. Function notation is if X is the independent variable and Y is the dependent variable, then the function notation for Y is f of x. And it's read f of x, where f names the function. Basically what this means, f of x is fancy for y. F of x is the same thing as y. Okay, we just denote f of x as the function notation for y. Alright, so f of x is fancy for y. A lot of times students see f of x and they start freaking out. They're like, oh my gosh, something totally new, I don't know it. F of x is just fancy for y. Okay. Independent variable. Think about in science terms. What's an independent variable, guys? In science terms, independent variable is what? That's the ones you can change, right? You control it. That's why it's independent. You're controlling it. It's the same thing here. Independent variable is the input of a function. A variable whose value determines the value of the output. I control what I'm going to put in. Okay, so if I want to put in x equals 1, I'm going to put in 1. If I control x equals 2, I'm going to put in 2, 3, 4, 10, 20, 100. I control what goes in. And the independent variable is what goes in. What comes out is what's known as the dependent variable. So the output, or y, or f of x, what we're talking about today, is what is known as the dependent variable. It's what's going to come out. So I'm going to put input in. My output comes out. That's my dependent variable. All right? So here's what this looks like here. You can use function notation to write a function. So again, remember, this is read f of x. All right, equals 2x minus 3. I can evaluate for functions. So I can evaluate for f of 0, f of 1/2, f of negative 2. I'm going to do f of 0 for this top function right here. If I do f of 0, 0 is going to be my input. What do I plug 0 in for? X. So that's like saying 2 times 0 minus 3. What's 2 times 0? 0. Minus 3? Boom. That would be my answer there. 0 is my input, and negative 3 is my output. All right? And I can do the same thing for down here. They had 0 go in for x. Okay? Notice they have 0 squared times 2 minus 0 plus 1. We get 1. Okay? It's input-output values. I'm substituting my input in, and the answer I get back out is my output value. Input-output. So let's see what this looks like here. Number 1. For each function, evaluate f of 0, f of 3/2, and f of negative 1. All right, so first what I'm going to do is I want to do f of 0 here. So I'm doing f of 0. I plug 0 in for x squared. Or sorry, 0 in for x. Now I just go through the order of operations. What does 0 squared get me? 0. Times 4. What's 0 times 4? 0. Minus 2. Negative 2 is my answer there. Nice job.
Wait, what about the f?
The f, remember, that's just my fancy function.
What about the 3 over 2 at the top?
I do that secondly. Each of these is a separate problem, bud. This is like 3 problems in one. Because I'm just going to get 3 different answers now. So I plug each one in separately. Like notice next here, Chow, I'm going to do the 3/2. Okay? So now I'm going to do the 3/2. All right, notice I have 3/2 squared. What does 3/2 squared get me? What? 3/2 squared. So what's 3/2 times 3/2? Isn't it 9/4? 3 times 3 gets me 9. 4 times, or 2 times 2 gets me 4, right? So I have 4 times 9/4 minus 2. Now what's 4 times 9/4 going to get me? What can I cross cancel there?
Yeah.
Can I get rid of my 4s? Yeah, I can get rid of those 4s. What's 9 minus 2? Hey, my answer there is 7. Okay. A lot of times students like to freak out when they get these fraction ones. More often than not, you can probably simplify or cross cancel and get easier problems. They just give you those fractions to try and challenge you a little bit. Next one, I have negative 1. Notice I plug negative 1 in. Always plugged in at the parentheses, so I know where that negative goes. What's negative 1 squared going to get me? 1. 1 times 4 is? 4. So I have 4 minus 2, which gets me 2. There's my answer. Input-output functions. I'm plugging the input in. What I get out is my output. Next one, I'm going to do 0. Bell, I'm going to plug 0 in for x here. What's negative 2 times 0, Bell? Plus 10? There's my answer, 10. Next, I'm going to plug in 3 halves. So I have negative 2 times 3 halves plus 10. Now again, we start freaking out like, oh my gosh, 3 halves. What do you notice I can do, guys? Okay. Do I get rid of the negative though? No. What's that going to become? So I have negative 3 plus 10, which now gets me 7. Recognize that the negative doesn't go away. It's just the 3's that I can cross cancel. Okay, kind of important on a problem like that. Then I have negative 1. So I have negative 2, parentheses, negative 1 plus 10. What's negative 2 times negative 1, Hannah?
2.
Plus 10? Nice job, Hannah. And 12 is my answer. All right, let's try number 3. Plug 0 in again. Now, what do you notice about my x's? I have multiple x's, right? So 0's got to go in for both x's now. 0's going in for both. Okay. So I get 0 squared plus 6 times 0. Rob, what's 0 squared going to get me? What's 6 times 0 going to get me? 0 plus 0 is still? No, you're right. Well, and 0 plus 0 is still going to get me? 0. Nice job, sir. You're thinking 0 is the next exponent, weren't you? All right, next I have 3 halves. Okay, now this one's actually going to be a little bit tougher. This one, there's no really cross-canceling here. So I have 3 halves squared plus 6 times 3 halves.
9/4.
Okay, so 3 halves squared is 9/4. Nice job, Chow. Plus, now what's 6 times 3 halves going to get me? I can technically cross-cancel a little bit and get rid of it, or I can just multiply. What's 6 times 3?
6 over 1 or something.
I can do like 6 over 1, yeah. So what's 6 times 3 going to get me? 18 over 2 gets me 9, right? So I have 9/4 plus 9. Let's simplify 9/4 here. What's 9/4 simplified down as a fraction? 2 1/4? Is it 9/4? 2 1/4? So I have 2 1/4 plus 9. What's 2 1/4 plus 9 going to get me? 11 1/4. So that one's a little bit tougher because I actually have to do some work, some fractions there. Okay? And then the last one, negative 1. I have negative 1 squared plus 6 times negative 1. Negative 1 squared is what, Jace? 1. What's 6 times negative 1, Jace? So what's 1 minus 6, Jace? Negative 5. Good work, sir. So there's my answers. Okay. Take a couple seconds, try these 2 on your own. All right? Again, you should get 3 answers. You should have an answer of f of 0 equals, f of negative 1 equals, and f of 1/2 equals. And same thing for number 5. F of 0 equals, f of negative 1 equals, f of 1/2 equals.
So that x equals...
All right, let's look at number 4 here. I have f of 0. When I evaluate for f of 0, what do I get, Jake King?
Negative 2.
Nice job. When I do negative 1, Joe, f of negative 1 is going to give me what? 2. F of 1/2 is going to give me what? Katie.
Yeah, I got 2 too.
I think it's negative 1.
How?
Because I'm going to plug it in, right? So I have 4 times 1/2 squared minus 2. 1/2 squared gets me 1/4. Because 1/2 times 1/2 is 1/4.
Oh, I thought it was 1.
We're not adding them. We're multiplying them, right?
Yeah.
So now I cross cancel and I get 1 minus 2, which is negative 1. Okay, 5. F of 0 gets me what, Crump?
10.
Good work. F of negative 1 gets me what, Rob?
I didn't get that.
So let's plug negative 1 in here. So negative 2 times negative 1 plus 10. What's negative 2 times negative 1?
2.
Plus 10. Good work, sir. And then I have f of 1/2. Joe Daniels, what's f of 1/2?
9.
9. Good work, sir.
Get that 9.
How to get 9?
Yeah.
So I have negative 2 times 1/2 plus 10. I'm going to cross cancel there.
And then you have 1.
And then I have negative 1 plus 10. That negative still got to stay.
Okay.
So I get negative 1 plus 10, which is then 9.
Yeah, I didn't know it was doing the negative.
Yep, it's still going to be there with just a positive with the 1 then. Good work. So last thing we're going to talk about today is we can graph these functions. All right? So we can graph them. Remember, what is f of x fancy for? F of x is really just fancy for y. Okay, f of x stands fancy for y. So when I graph these, I want to pick x values. Okay, I want to pick x values. Notice, what x values did I pick here? I picked some what? I got some negatives, I got some positives. I also have a what? 0. Okay, I always want a few negatives, always want a few positives. You always want at least 5 numbers to evaluate. 3 is not enough. 5 is a pretty good sample. Okay, you always want 5 numbers, a couple negatives, a couple positives. Why do we choose like 1 and -1 and 2 and -2? Why? They're easy numbers to compute, right? Yeah, I don't want to pick like 1/2. I don't want to pick like 2/3, 4/9. I mean, I can. That just makes it tougher, right? I always want to pick some easy numbers that I can compute. Okay. So notice, what am I doing here? I'm going to get ordered pairs. -2, 7. -1, 5. 0, 3. Okay. And then I just plot those coordinates. So -2, 7, you know. I'm plotting those coordinates. And then I'm just going to draw my line on top. And that's going to be the graphing my function. Okay, so number 5 here. Now, these are the table the book gave you here. What's wrong with the table they gave you? What do they not have? Negatives. I would suggest always having a few negatives. Okay, so recognize that. They give you 0, 1, 2, 3, 4, which are good numbers, but I always suggest having a few negatives in there because negatives do some different things to graphs sometimes. Okay, so I'm going to plug 0 in. So I get 2 times 0 minus 4. What's 2 times 0? Minus 4? So my ordered pair is going to be at 0, -4. Boom. Ordered pair. Next I'm going to do 1. So I have 2 times 1 minus 4. 2 times 1 gets me minus 4. -2. I get the ordered pair 1, -2. Next I have 2. So 2 times 2 minus 4. 2 times 2 gets me 4 minus 4. 0. So I have 2, 0. I'm going to do 3. So I have 2 times 3 minus 4. 2 times 3 is minus 4. 2. I get the coordinate 3, 2. And lastly, I have 4. So 2 times 4 minus 4. 2 times 4 is 8 minus 4. 4. Ordered pair is 4, 4. So I have my coordinates plotted. Now I can connect them all with my line. And there we go. Okay, so that's making a table and graph of the function there. All right, good work. Let's try number 6. I have make a table and graph of y equals x squared minus 3. So I'm going to make a table over here. What are some of the best values I want to choose? -2, -1, 0, 1, and 2. Okay, I'm going to plug it in. So I'm going to plug in -2 squared minus 3. Well, what's -2 squared? 4 minus 3? 1. So I get -2, 1. Okay. So next one I have -1 squared minus 3. What's -1 squared give me? 1 minus 3? -2. So I get -1, -2. Then I have 0. So 0 squared minus 3. 0 squared is? Minus 3? -3. 0, -3. Next I have 1. 1 squared minus 3. What's 1 squared? 1 minus 3? -2. So I have 1, -2. Then I have 2. 2 squared minus 3. 2 squared minus 3 gets me? 4 minus 3? I have the coordinate 2, 1. And if you look at my graph, I get kind of a U-shaped graph here. Does anybody know what this graph is actually called? Yes, sir. That is a parabola. Nice job, Rob. That'd be a parabola. We'll learn more about that actually next section. Okay, nice job. All right, last one here. Try number 7 on your own. Take a couple seconds, make a table, try number 7 on your own.
Haha.
I can multiply.
Here's your assignment.
Oh my